Welcome you all my lecture series of automata theory and compiler design. In the last video we have seen the analysis phase of a compiler like lexical analyzer, syntax analyzer and also the semantic analyzer. In today's video we are going to see about what are all the phases in the synthesis phase. So already you know that what are all the 6 phases of an compiler. In the previous video we are seeing about the lexical and syntax analyzer. What is a semantic analyzer means? That is the third phase of the compiler that take the parse tree as a output from the syntax analyzer and convert that parse tree into the annotated parse tree. So what is the difference between the parse tree and the annotated parse tree means that annotated parse tree produce some more information about the variable or identifier in the parse tree. For example, we are initializing one variable a means, so what are all the attribute belong to that variable, value and the type. So these information are given in the annotated parse tree by the semantic analyzer. That is the function of the semantic analyzer. Next is an intermediate code generation, that is the fourth phase of an compiler. The output of the intermediate code is a 3-address statement. So the 3-address statement means using the temporary variable, the operands and the operators and also the registers that statements are represented. So the intermediate code representation is represented in terms of either a 3-address statement or the syntax tree or the DAG representation. So these are all the 3 representation of an ICG. So most frequently used ICG representation is a 3-address statement. So the 3-address statement is represented in terms of a quadruples, triples and indirected triples. For example, considered our statement is the new value which is equal to old value plus fact star 1. So that statement is converted into the token as id1 id2 plus id3 star 1. So that tokens are converted into the 3-address statement using the temporary variable like that. temp 1ல நம்ம என்ன ஸ்டோர் பண்ணுறோன்னா, we are converting our integer to the real as a 1. Next temp 2ல we are multiplying that id3 along from id3 means fact, the id3 by the temp 1 value. Next in the temp 3 id2 is plus with temp 2 value. Finally the whole result in the temp 3 that is assigned to the id1. So these are all the 3-address statement produces by the single above statement. Yeah. Why we use the 3-address statement means the conversion of assembly code is very easy when we are giving input as a 3-address statement. Next is the code optimizer. The function of code optimizer means convert our 3-address statement into the optimized code. So what is an optimized code means some statements are redundant in the statement means that could be reduced, and also if some statement is a cost effective. For example, instead of the multiplication wherever we use addition means that statement is also used. So what is the outcome, what is the advantages of optimization means it produces the the performance are increased, and also it reduces the statement level. So these are all the advantages of an optimization. For example, in the previous intermediate code, we are having a 4 set of temporary statement. Instead of the 4 set of temporary statement, that could be reduced into the 2 set of statements like then the right hand side. For example, we are adding, you are using only one temporary variable, so that id3 is multiplied by 1, and also that id2 is plus by temp 1, it is stored in the id1. So instead of the 4 statement we are using the 2 statement, that is an optimized code of the above statement. Next is the code generator. The code generator take the optimized code as an input and produces output as an assembly level code. I already told that what is an assembly level code. It is a mnemonics. Using the mnemonics we can represent that statement statement ID1, ID2 plus ID3 plus 1. That statement is converted to the assembly code by first using the registers. We are storing and adding, and all the operator are done in terms of a register only. First in the register 1, ID3 values are stored. Next we multiplied that register 1 value with the 1. After that we are moving register 2 to the ID2 and adding that R1 value with R2 value. Finally the result is stored in the R1. That R1 result is moved into the ID1. These are all the mnemonics code, that is an assembly code for the above statement. So for the code generator, we have to consider several issues to convert our 3-address statement into the assembly level code. That could be detailedly we are seen in the next coming video. I hope you will understand what are all the synthesis phase. In the synthesis phase, our source program is converted into the target program. Thank you.